Hello everyone, today I'm looking at the lucky numbers in a matrix. You're given an m by n matrix of distinct numbers. Return all lucky numbers in the matrix in any order. A lucky number is an element of the matrix, and it's the minimum element in the row, and also the maximum in the column. So to find this, we need to get all row minimums, get all column maximums, and find the intersection of those. So one thing I think everybody knows about is sets have O of 1 lookup, so why don't we build some row minimum and column maximum sets? So let row mins equal new set, comma, let column maxes equal new set. I don't think you like that. Semicolon. And let's find all the row minimums. We're going to iterate over the matrix. Let I equal 0. I is less than the matrix dot the length. I plus plus. And so how can we, for each nested array, get the minimum? Well, you already know you can use a a spread operator, as it's called, to pass in all the elements from a array. So if the nested array is located in a 2D array called matrix, and it's one of the indices, we can use I, and if you want to pass all, so now we have all the elements just as they are, and if we surround these in parentheses like so, and put the word math.min, it will find the smallest number of that nested array. And what we want to do with that is put it inside. All right, so we're going to put this surrounded in parentheses. And then we're going to basically row mins.add. Add it to the row minimum. Okay, so now we need to find the maximum in the column. So for each column, we're going to iterate over this, and it's going to be let j equal 0. And then how many columns do we have? 1, 2, 3. I just looked at the row, but that tells you how many columns you have. So we can just take one of the rows. We don't need to make it iterable. We can just say matrix 0 for one of the rows. So take the length, and that's how many columns. Now, j++. So that's how many times we're going to do it, is 3. 3 columns based on row length. Okay. And so now we need to set the max, but there's a problem. What do we initialize it as, you know? So negative infinity will make it so no matter what the first number we set as the max is, it will be the max so far, because even 0 is more than negative infinity. Even negative 5 would be more than negative, you know? So that's a good approach. And so now For each element in a row, we're going to check its column counterparts. So let's go. For let I equal 0, I is less than matrix dot length I plus plus. And so the max is going to be math dot max. It's either going to be what we've got so far, or it's going to be the element in that row at that index. And so whatever the max is we're left at the end is what we want to add to column maxes. So column maxes dot add the max. Lastly, we're going to want to we're going to return the result, right? So return result, but what is result? Result is a array containing the lucky numbers. So let result equal an array, and then we just need to check the intersection of the sets we've created. So for let value of row min, if it's in the maximum, then push it onto the result. Then push it onto the result, because then it is a lucky number. Time limit exceeded. There is some timeout problem. Set I matrix I row mins dot add math dot min dot matrix I for j equals 0 matrix 0 j plus plus max is negative infinity I less than matrix dot length I plus plus max math max matrix ij column maxes row s, add the s. It's usually something like that, where it's like a spelling issue, right? So matrix dot length while j is less than matrix dot length. Okay. I'm just a mere mortal. I'm just a human. I make mistakes. And with that thought, I hope you guys have a nice day.